Welcome to This Explainer. Today we're diving into something really mind-bending. We are impartially unpacking a radically alternative framework from our source documents, and it's called spatial morphology. Now, fair warning, this isn't just a minor tweak to standard physics. We're talking about an attempt to completely rewrite the fundamental rules of reality from the ground up. Here is our roadmap for today. We're going to cover 1. The morphology of the universe, 2. Gravity and electromagnetism, 3. Real proportionality in mathematics, 4. Solving the millennium problems, and finally, 5. The illusion of particles. Let's just jump right in, shall we?
Section 1. The morphology of the universe.
Okay, so according to this framework, we've got to completely stop looking at the universe as this massive, empty container just filled with tiny floating particles. Instead, the authors want us to imagine reality as a single, continuous, geometric fluid. What changes isn't the actual stuff itself, but just the level of tension and condensation. It's kind of like water turning into ice. Same fundamental substance, just a different state. Think about what that actually means. Under this model, empty space literally doesn't exist. It proposes that what we bump into every day and call solid matter is essentially just light that's trapped inside highly condensed space. The authors argue that institutional science is really limiting nature by chopping it up into these rigid, compartmentalized particle models. Spatial morphology, on the other hand, argues for a beautifully simple universe, driven entirely by geometry. Moving right along to Section 2, Gravity and Electromagnetism. Notice how elegantly this breaks things down into a really simple dualism. Look at how matter is described here. Gravity isn't some invisible tractor beam pulling us down. It's actually just space that is highly compressed and tense, which we end up feeling as mass. And on the flip side, electromagnetism operates in an unfolded morphology. It's a low-density vacuum where light can displace the fluid freely. To test this observationally, the authors look at gravitational waves. If you calculate the injected energy of a detected 150 Hz wave, you get an absurdly tiny number. We're talking 6.2 times 10 to the negative 13 electron volts. To put that into perspective, that is basically absolute zero. It's literally billions of times weaker than the energy of a single lonely electron. Because this astronomically tiny amount of energy is spread out over a massive distance of 2,000 kilometers, it completely sidesteps a Schwarzschild mathematical collapse. Basically, it doesn't just infinitely condense into a black hole. For the authors, this math proves that gravity is just stretched spatial morphology, not some undiscovered dense little particle called a graviton.
All right, Section 3. Real proportionality and mathematics.
Now, the source material makes a really bold claim here. It claims that our standard base 10 math, the linear 1, 2, 3 counting system we all use every day, is actually fundamentally flawed for solving the universe's true mysteries. Think of it like rigid stairs. It's a fragmented shadow that creates overflow arrows in physics simulations. Instead, the theory uses something called real correspondence. This system maps problems not as numbers to be counted, but as fluid topological imbalances, relying heavily on relative proportionality. By applying this specific logarithmic formula, where you calculate the natural log of x over y divided by a topological constant, the value of a number stops being a fixed, rigid amount. Instead, it becomes this relative, flexible position inside an infinite, nonlinear progression. And honestly, this exact mathematical shift sets the stage to tackle the impossible. Which brings us to Section 4, Solving the Millennium Problems. Let's actually apply this new lens to the infamous P versus NP cryptography problem. This is the math that currently keeps your bank account secure, right? Normally, cracking 256-bit encryption requires virtually impossible brute force counting operations. But under this model, no way. You don't count at all. You treat the encryption as a spatial perturbation, and you apply an inverse resolution function to search for the specific geometric mold that allows frictionless data flow. Using this massive proportionality inverse resolution equation, the goal is to basically collapse all that massive NP complexity in what's called constant O of 1 time. In plain English, it means solving it almost instantly. Because you aren't iterating or counting operations one by one, you're simply mapping the phase convergence to instantly find the point of minimum computing latency. And remarkably, applying this exact same logic works for fluid dynamics too, offering a proposed answer to the Navier-Stokes equations. In their simulation, an airplane wing hitting supersonic air isn't just some solid wall crashing into a gas. It's defined as a substrate with its own specific latency. Under this integral equation,
Turbulence isn't a chaotic mathematical explosion. It's framed predictably as just a desynchronization of phases between two substrates. It even proposes an answer to the Riemann hypothesis. The big mystery about the distribution of prime numbers. If you graph primes using their real correspondence metric instead of base 10, the text argues that primes are not random, unpredictable mysteries at all. They are simply predictable nodes of destructive interference, occurring right along the one-half critical line within a system of intrinsic resonance.
Finally, let's wrap up with Section 5, the illusion of particles. Looking at these equations, you can see how they complement each other. Their adaptation for Yang-Mills theory argues that mass is not some intrinsic, permanent constant, but just the pressure of a full environment. And then the math shows that when the wave phase of one morphology exactly mirrors the opposite of another, their sum equals 0. Mathematically speaking, the quote-unquote particle just completely cancels out and disappears. Poof. The source document argues that the strong nuclear force perfectly illustrates this illusion. Look at the Kr term in the potential energy formula. This actually means that as distance r increases, the force of attraction grows linearly. It acts exactly like a literal elastic band. You can't separate the pieces because they aren't distinct pieces to begin with. They are just bound variations of the exact same continuous medium. So this leaves us with a profound, almost unsettling paradigm shift to chew on. Are we artificially overcomplicating physics? Have we spent a century forcing nature into these rigid, compartmentalized models, hunting for smaller and smaller solid particles, when we should have been exploring the elegant geometry of a single unified fluid? It's a fascinating framework that begs the ultimate question. What if the empty space you're sitting in right now isn't empty at all?